Now that we're able to convert complex numbers from Cartesian form into polar form, we can look at some of the advantages of doing so. Now on the right hand side I've made a couple of notes regarding the multiplication of two complex numbers in polar form and the division of two complex numbers in polar form. Now the simple rule is when we multiply two complex numbers in polar form, we multiply the modulus of each of those together and we add the argument of each of those together. So in effect, we multiply the magnitudes and we add the angles. When we divide one complex number by another, we divide the modulus or divide the magnitude and we subtract the arguments from each other. And we'll do some examples, but they're based around these simple rules. And this is one of the huge advantages of working in polar form because multiplication and division is much more straightforward. Just before we do that, I just want to talk briefly about this angle here of minus 56.3. Now, although we've expressed that as a negative angle, we could just as easily have expressed it as a positive angle. Because if that angle is minus 56.3, as shown on the diagram here, then we could also have expressed that as a positive, and the positive angle would have been this angle here. Well, hopefully from observation you can see that the angle drawn in red there is just 360 minus the 56.3, which is 303.7. So the important thing here is we do have options. We could specify that as minus 56.3, or we could have expressed it as 303.7. Both of those would be accurate. But let's work with what we had originally, an argument of minus 56.3. And we're going to perform some basic operations. First of all, let's do Z1 times Z2. Now we've already said in order to find the modulus or the magnitude of Z1 plus Z2, all we need to do is multiply the two individual moduluses together. So in this case it would be 5.0 for Z1 times 3.6 for Z2. And that gives us a new modulus of Z1 times Z2 of exactly 18.0. And when we want to work out the argument, so we've got the argument of Z1 times Z2, we're multiplying those two together. We just need to add the two arguments together. So we have 36.9, and to that we're adding, just take care here because we're adding a minus 56.3. And that's the same as 36.9 minus 56.3. which comes out to be minus 19.4 degrees. Therefore, Z1 times Z2 can be written as follows: 18.0 at an angle of minus 19.4 degrees. And remember that we could always express that as a positive argument if we wished. Let's look at another example, except this time we're going to do a division. So this time let's do Z2 divided by Z3. Well, if we do Z2 divided by Z3, in effect what we have is 3.6 at an angle of minus 56.3 divided by 5.4 at an angle of 158.2. Both of these angles are in degrees. So this time we need to divide the modulus. So the modulus this time of Z2 over Z3 is 3.6 over 5.4, which equals 0.6 recurring, so we'll write 0.67. And for the angle, we need to subtract 158.2 from minus 56.3. So we can write the argument of Z2 over Z3 equals the number that's on the top of the fraction, minus 56.3, or the argument on top of the fraction, I should say, minus 158.2, giving us an answer of minus 214.5. Now that one is probably going to be better expressed as a positive because minus 214.5, we go minus 180. So minus 214.5 is going to be somewhere around here. To express that as a positive, all we need to do is 360 minus the 214.5, and that will give us this angle here. So minus 214.5 is just the same as saying 145.5. So we can write Z2 divided by Z3 equals 0.67 at an angle of 145.5 degrees. Let's take a look at one more, and this time we'll do Z1 divided by Z2. Well, Z1 is 5.0 on an angle of 36.9 degrees. Z2 is 3.6 on an angle of minus 56.3. The modulus of Z1 over Z2 then is just 5.0 divided by 3.6, which gives us 1.39. And the argument of Z1 over Z2 is the number on the top, the 36.9, minus the number on the bottom, minus 56.3. Recall that that's just the same as adding 56.3, and that comes out to be 93.2. Therefore, Z1 over Z2 equals 1.39 on an angle of 93.2 degrees. So there we've seen how to apply the simple rules for the multiplication of two complex numbers and the division of one complex number by another. And this method works providing we're working with complex numbers in their polar form.